Hello and welcome everybody to a new video. So in this video, we're going to be talking about this little guy in front of you here. So if you followed my channel for a while, you probably have seen this, but I've probably never actually talked about it before. So I use this in a lot of my videos to kind of show off a little piece of work that I've done, and it's kind of it was a DIY turntable thing that I made ages ago for basically for filming stuff. So if I flick the switch here, you'll see what I mean. There we go. It's a little turntable. So you've got a couple of switches on the front, on off switch. It has a switch here for changing direction. And it has a little knob on the front here that you can use to change the speed. And you may notice there that with that tiny little adjustment I did, the speed changed dramatically. Um, and so that's kind of an example of why I'm showing you this today. Um, So this little guy, it works pretty well. Um, I've had it for a long time now. I threw it together years ago, and yeah, it works well, but it needs some love. So what I'm going to do is going to be a short, quick and dirty video. I'm going to pull this guy apart, and effectively I want to replace this knob. It's a currently a just a regular potentiometer. I want to change it for a little encoder, so that I can make it linear, so that I can more finely adjust that speed and kind of have whatever resolution I would like on the speed. And I also want to reprogram the code that is running the motor driver in here because it's not very good. So I'd like to basically give myself more granular control and better kind of range of speed that I can move through with it. So it's not going to be a huge amount to this. I'm going to crack this guy open. I'll show you guys inside it. There'll be a little rewiring, replacing the pot for an encoder, and then it'll mostly just be a little bit of programming on the Arduino to make it work. So that's it. You guys can join along. And I do apologize, my voice probably sounds a bit croaky. I'm a little bit sick at the moment, so I'm probably not going to do too much talking in this video, but I'll jump in here and there to talk about stuff and explain stuff. All right, so these are the internals of our little machine here. So we have this rig set up here, which is the main output. Stepper motors underneath here, a little belt tensioning system. That's just a little 3D printed bracket that it all mounts to. Then we got our main electronics board here. It's very simple, just an Arduino Nano stepper driver, and all the I/O is all on that. Other stuff: on-off switch, voltage regulator. This is just a switch for the state switch between forwards and backwards. And then we've got our little potentiometer here for our speed. So main thing I'm going to do, I'm going to take the board out, main board out. I'm going to take this potentiometer off and replace it with this little rotary encoder. Only thing, well, the main part of the modification I have to do, main reason why I have to remove this is that I need to solder, make another trace somewhere because the potentiometer just uses one wire, whereas this guy needs two wires. So that's the main thing I have to do, is wire in those two wires somewhere onto this board to talk to the Nano, and then reprogram the whole thing. So I'm going to take it apart and do some rewiring. This is just a little bit of disassembly, nothing crazy going on here. One thing I did remember when I was taking this apart, that for some reason I used the longest screws in existence to secure the PCB standoffs in. I don't know why. When I was putting it back together, I only used two because I did not want to screw them all the way back in. I'm kind of lazy like that sometimes. Last little bit that was a little tricky was I actually super glued the pot in the last time I did this, so I had to refun it quite a bit with the pliers to get it out, but didn't end up damaging it or anything in the end. The hole was intact, so I could just pop the new encoder in. This little PCB board was, or proto board was a little bit of a mess, kind of wires everywhere and some dodgy solder joints. So I touched up a few little places, and basically all I had to do was stick a new 5-pin header on it and wire up four of them. There is a little switch connector on the encoder, but I'm not using that for anything. I just left it there in case I decide in the future that I want to use it for something. with our soldering done, this is back to our final assembly. Some of this was a little bit painful because some of the wires I'd used back when I built this originally are very stiff and quite chunky for this purpose, so kind of had to bend some stuff around and get it in. It all worked fine. Yeah, just a little bit of a mess. I was just happy I didn't break anything taking it apart and putting it back together again. Last little bit then, just securing the new encoder. This time I decided to use hot glue instead of super glue to make it a little bit easier if I need to take it apart again. Okay, so we have our wiring done, everything's back together, and we have some new code written, which is making this thing work a hell of a lot better. So I'll throw up the old code on the screen here, and it's ridiculously simple. I was just reading value from a potentiometer, taking that value, doing some very minor transformation on it, and then plugging it into the delay microseconds function in the Arduino, which effectively delayed a high-low pulse by a certain period that is being sent to the stepper driver, which effectively changes the speed that the motor is going to run at. So the new code does basically the exact same thing, except instead of just using the analog read to read a potentiometer, we're using a library, the encoder library, to read a value from the encoder. We have to do a little bit of logic just to make sure that the value stays within some bounds that I kind of messed around with to pick what I wanted to. And then the speed control is the exact same. It's the length of delay between a high-low pulse being sent to the stepper driver. So very simple. Unintuitively, the larger the value, the slower the motor will pulse, because you've got a larger delay between the pulses, which means the stepper will step less frequently, meaning it'll run slower. So that's it. All that said, let's turn it on. I'll stick on the little turntable plate just temporarily so we can have a look at it, and we'll see it spinning. And you'll see it's a lot more controllable, less sensitive than it was before. So we'll flick the power switch, and there we go. So that's spinning at like the average speed. I should probably put something on it so you can see it a bit easier. Yeah, so that's spinning at like the sort of average speed. And as I twist the knob to the left, it's slowing down. There we go. So I think, yeah, that's oh, and go slower. Yeah, that's as slow as it's getting now. So I've hit the bottom. It's not going to go any slower. The change direction still works. And I can turn it up then. Woo! And there we have it. That's it. Job done. I'm going to pop the cap off this. I'm going to pop the lid back on, screw it back up. Job done. Simple, quick, easy project. Love it when a plan comes together. So there we have it, folks. A quick, simple little project. Just getting a little bit of new life into some of my old tools, which is always good. So yeah, you'll see this guy around a lot. You've probably seen him before. Just loves sitting there spinning things. So anyway, thanks for watching, guys, and I will see you in the next one.